Hi everyone, this is the first video of our series called Simulate Everything. So here we will talk about the Monte Carlo simulation or other simulations, how to do integration, differentiation using numerical approach and simulation approach. And for all the simulation, the first concept which everybody needs to know is how to generate a random number. So let us begin with it. So if I write is equal to and then R, A and D and two parentheses, that will give me a random number between 0 and 1. Is that true? Let me copy the same formula again and again in other cells, and now you can see that my first number is 0.27, the second is 0.87, third is 0.82, 0.21, 0.61. So these numbers are all different, but they are all between 0 and 1. And what I can also do is I can grab this number here, and then I can again copy this number again. So if you see that the numbers are changing, so if I click on this formula and then press enter, all the number changes again because they are generated again. So let me take both of these columns and let's plot a graph here. So if I plot a scatter graph, then you can see that the numbers are all random, but they are between 0 and 1. So both on the x-axis it's 0 to 1, and on the y-axis it's 0 to 1. But there are not lot of numbers here. So what I'll do is I'll generate more numbers and then do the plot again. So let me do that. So again I'll grab the two cells and I'll drag them down. So I have around 900 points, and it doesn't matter how many points I have. And then I'll say insert and then a scatter plot again. So now you can see, because now I have lot of points, all the points are between 0 and 1. So this is 0 to 1 on x-axis and 0 to 1 on y-axis. So this seems like little fun. So what happened is we put so many points that we fill up this square from 0 to 1. Now what if we have to generate a number which is not between 0 to 1 but between something else? So here what will I do is I double click on this and I say here is 1 minus 2 into random number. So if I do that, what will happen is that the random number will be get multiplied by 2 and it gets subtracted by 1. So what will happen? It will change the random number from 0 to 1 to minus 1 to 1. So let me see if it's possible. So I just when I select the cell, I bring my cursor to the end of the cell and I double click on it. So when I double click on it, all the numbers in this column will change to the same formula which I type in the first cell. So now you can see that the numbers on the x-axis has changed from minus 1 to 1. So because we have modified the formula here, so it's minus 1 to 1 on this graph. Now if I do the same thing for this, so I grab this number and bring it here, or let me type the formula again. So that is 1 minus 2 into random number. And if I bring the cursor again to the end of the cell and I double click on it, it will also change all the numbers in the same column. And now the numbers are minus 1 to 1 and minus 1 to 1 in both x and y plane. So now you can see that we have a rectangle which looks little different. So now all you need to do, suppose if you wanna get a number between minus 10 and 10, all you need to do is multiply this thing, the whole thing, by 10. So if I do this and I double click on this, now you can see it goes from minus 10 to 10. And same if I want to do this like 15, so I will multiply. So here instead of 10 I'm using 15 as example. So if I do 15, then you can see now these numbers are changed from minus 15 to 15 and these are changed from minus 10 to 10. So this is how we generate a random number, right? So I hope this video helped, and I will see you again where we will use this random number to do some simulations. Okay, thank you. Hi everyone. In the last video, we talked about how to generate a random number. Here we will talk about how to generate a random walk. So let me give you a little brief introduction to the random numbers again. So to generate a random number in Excel, we'll write is equal to RAND and parenthesis. So that will give me a number between 0 to 1. Now, if I want a number from -1 to 1, then instead of RAND, I will say uh, 1 minus 2 into RAND. And if I do that, it will give me a number between -1 to 1, right? So if I copy this number again in the second column, and then I copy the same numbers again and again until around 1000 points, right? Now if I go back up again, so these are the random numbers, and suppose if this is a x-axis and this is y-axis, then I can do a plot and select both and say scatter plot. So now you can see that these numbers are completely random between -1 and 1, both on x-axis and y-axis. So these are the points which are plotted on a 2D graph. Now I'll delete this graph and I'll go back here. No, so my purpose is to generate a random walk. So for that one, what I'll do is I'll use name the first axis as dx and the second axis as dy. So these are dx and dy, and we start with x and y, and we consider x to be 0 and y to be 0. So because we are starting from the center, or let's start from the origin, so you can always change this number. It doesn't have to start from 0, but this is just a example here. So now what I'll do is here I'll say x, which is the initial position, plus delta x the change, what kind of steps we will be taking. So I'll say enter, right? And then I'll drag the same formula here. So here it says the first step is a random number plus the initial position. So that's our first step. Now if you want to do a second step, I'll drag this down here. So you can see the second step is, it starts from first step, which is says d3, and then it adds a random number into it again. So it says that I know where my position is, but I don't know where my next position is, so I'll just add a random direction into it in the x-axis. And same way I'll say I'll generate a number and I'll go into the y-axis as again a random number, and then I will keep doing this. So what I need to do to keep doing this is just select these two cells, bring the cursor on the corner and press double click, and it will just drag the same formula until the end, right? So we are not using this two random numbers, so I can delete this. So now you can see that if I click on this again and again, the random numbers will change. And now let's see if I plot this, what will happen. So I will say insert and then this. So now you can see that this is how the curves look like. So instead of scatter plot, I need to use a line here. If I use a line, say change chart type, and I'll use a line here. So this is it. So now you can see this is a random box. So if I double click on this again and press enter, now it changes. If I double click on it and then press enter, so you can see it starts from 0, then it goes in negative direction in the x-axis and positive in the y-axis, and then goes back again and then moves. So it's very random. So if I click on this again and do this again, so now you can see that each time I do this, the movement is different. So this is also called Brownian motion, and random number is also another uh, popular terms for it. So now what I can do is I can copy the same formula, same everything, and paste it here. So if I do this, what will happen is that I have um, same thing, but I have another series of x and y, and I can plot this on this same graph. So what I need to do is select data and say add, and then I'll say x-axis uh, to be this. It starts from here, it goes until here, and then y-axis is this, starts from here, go until here. And if I do this, then I have two random walks on the same graph. So now you can see that I have two random walks on the same graph, and they have a different color. So you can see that this if I click on enter and then say, so each time the walks are random and they are independent of each other, you can see. So now because I started one of them at 0 and another, both of them are starting from 0, so let's see what happen if I start another one at some other point. So I will write 100 here, and then you can see that if I do this, these two are starting way far from each other and they never touch each other, right? So they're almost far from each other, but if I bring them closer, I write a 50 here, then you can see here closer, but still they're not overlapping. And let me say 20 here, 20, 40 here, and now you can see. So we can do all kind of simulations and random walk simulation using the Excel sheet, and it's a very visual, and you can also see all the simulation steps in front of you, all the calculation in front of you. So it's very easy to track any mistake if any you have done. So if I just plot the x-axis, then you will see, like suppose if I'm doing the troubleshooting, so you need to first make sure that the both random numbers you are generating, they are completely random, and that's true. When I plot them, you can see that all the numbers are random and they do lie in the range we want them. And if I plot the x-axis by itself, then it should be like a random walk in 2 dimensions, so that is also true. So you can see that the x-axis is in random walk. So if I click again, so it goes, but it's in 1 dimension. And same goes if I drag the same graph for y-axis, then y-axis is also a random walk. So this is the troubleshooting you can do if you are unable to generate this. But I hope this is a very simple tutorial and you should be able to follow the steps and generate this simulation, and I think it's a lot of fun. And please don't hesitate to give your comments or email me with any questions if you have any problems generating this walk. And we will go next and understand the concepts of Monte Carlo simulation and how these random walks are useful to get something useful or simulate something which is more closer to life. And I'll see you again. Thank you. Hi everyone, in this video we'll talk about how we can calculate the value of pi using a Monte Carlo simulation approach. Uh, just a brief idea. So to calculate the value of pi, what we'll do is we'll calculate the area of a circle, and we will calculate the area without using a traditional formula which is pi r square. Instead we will use simulation to calculate the area. So once we have the area, then we can use the formula to calculate the value of pi. And to do that, to calculate the area of the circle, we will enclose this circle into a square. So let me draw it. So we'll draw a square around the circle like this, and if we have this square, then we know the area of the square, and then we will use the Monte Carlo to calculate the fraction of the area of the circle, and from that we will be able to calculate the area of the circle, and later we will be able to calculate the value of pi. So even if this is not very clear to you, let's go to the simulations, and once we do the simulation step by step, everything will become more clear. So let's start. So for this simulation, first we need to learn about the random numbers. So in Excel we can do the random numbers by using is equal to RAND and then parenthesis. It give me a random number between 0 and 1. I can copy the same formula here and call this as x-axis and this as y-axis, right? So what I did here is I have a number, I plotted, I generate a coordinate of a number which can be anywhere on x and y-axis. So this is ranges from this is the x coordinate and this is the y coordinate. So I can generate many points like this if I drag the same formula again and again below. So let me generate around uh, so I say 1 2 and let me generate around 1000 points. So I'll go here and you can see these are 1000 points here. So you can see this is a 1000 here, and these are all the random numbers. So if I use this all the random numbers and I make a plot of it, so I say insert. So what will I get? Will I get the points which are randomly placed between 0 and 1 both on x-axis and y-axis, and if we place them randomly, then ultimately we will fill up the whole uh, range, and if we fill up the whole range we will see a filled square, and that square is what we wanted. So now we can calculate the area of the square. We know the area of the square should be equal to side into side, and that will be 1. So here the area of the square is 1, right? So we generated the square. Now how will I move this square, the center of the square to 0? I want to do that to make my calculation simpler. So to do this, I'll change the random number range from 0 to 1 to -1 to 1. So I don't want them to go from 0 to 1. I want them to go from -1 to 1. So in that case, what will I do? I'll change the formula to 2 into random number. If I do this, my random number range will change from 0 to 2, right? And if I subtract this from 1, then the random number range will change from -1 to 1. So I'm doing this. I copy the same formula here and I drag the cursor to the end of the cell and I double click on it. So everything got changed, and now you can see that the square has changed from -1 to 1 both on x-axis and y-axis. So now what's the area of square? That is equal to 2, because now you can see the side is -1 to 1, so the total side is 2. So 2 into 2 is 4. So this is the area of the square. Number of points in square is equal to 1000. So that's equal to 1000. So that we know. So this is clear. Now we have to generate a circle. And how do we generate a circle? We know the equation of the circle is x square plus y square is equal to 1, right? So each coordinate has a particular distance from the center. So let me say what's the distance. So distance from the center, so this will be the distance from the center, and suppose the distance from the center, that will be given by x square plus y square. So this is, so you can see that this point is 1.185 units away from the center. and if I double click on this, then I'll get the range for all the points. Now how will I generate a circle? So a circle will be defined as any point which is less than 1 from the center. Why? Because to enclose that circle inside the square, the radius has to be 1 because it starts from 0. So in that case, I'll write a command here is equal to, if distance, this is the distance, right, is less than 1, then select x, otherwise don't select x but just put a 0. So this is a simple command. If even if you, when you try to type this command, it also give you the values you need to add. So you can, so it says if d5 is less than 1, d5 is the distance from the center is less than 1, then use x-axis, otherwise put 0. So this is number, and again I can write again, if distance from the center is less than 1, then use y-axis, otherwise 0. This is again another thing. So we can call this again as x and y, and we can call them as, so let me add some space here, so we can call them as circle, and this was square, right? So if I select both this point and double click on it, then I get the all the coordinates for the circle. So let me plot that. So I'll say insert and scatter plot. I don't know where the chart is. It's not here. Let me do it again. Yep. So here is the chart, and if I drag it down, so you can see we generated a circle. And I think it's amazing that you can use simulation to generate this kind of shapes, and it was really interesting when I first did that in Excel when I was in high school. So let's see if I plot the same circle on the square, then what it looks like. So let me delete this and use this graph and say select data and add x-axis, and it goes till 1008, then this one goes till 1008. So now you can see that this circle is actually inside that square, so everything seems to work fine, right? So let me delete this. So this is what we simulated. So now we have simulated a circle and a square, and the circle is inside the square. So how will I get the fraction of area of the circle? And to get that, again I need to, let me put that in the side, and what I need to do is I need to write a condition here, and that condition is equal to, if distance from the center is less than 1, then 1, otherwise 0. So what we'll do is whenever there is a point inside the circle, then it will count as 1, and if it not, it will count it as 0. So let me double click on it. So now you can see that here when the distance was 1.14, it counted as 0. Again when the distance was 1.09, it calculated as 0. In all the other cases it counted it as 1. So whenever there is a point inside the circle, it will count it, right? So now I will say with how many number of points in circle, that will be equal to sum of these, right? So I'll say sum, and I go until goes until 107. So I'll say 107. So it gives 792. So the total number of points in circle is 792. So fraction, area fraction of circle is equal to 1000 divided by, no, 786 divided by 1000. So that's the fraction of area of the circle. So now you can see that whenever I double click on a change, all the simulation is been redone by Excel, and therefore the number changes, and it changes again and again. And why this number is different each time is because we do not have enough data points. We used only 1000 data points, and in simulation it's very important that more data points you use, the more accuracy it is. So instead of using 1000 points, if you use 10,000 points, then the accuracy will be much higher, and the value of the pi will be more accurate, right? So now what I'll do, I'll say to calculate the area of the circle, so insert, insert, so area of circle is equal to, that's equal to pi r square. So say pi, and what is r square? R square, r is 1 here, so that will be equal to uh, pi, pi. So the area of the circle is pi because r is 1, because r is equal to 1, right? Now we know the fraction of the circle, and we know the area of the circle, and we know the area of the square. So if we do all the calculation, value of pi will be equal to area fraction divided by 4. Oh, sorry, that will be equal to area fraction multiplied by 4. Sorry about that confusion. So in that case, uh, it will be 3.22. So now you can see that it is not very close to 3.14, but if you do the simulation again and again, it gives us a number which is close to 3.44, and this is the value of pi. And to get more accuracy, we need to do more data points. So if I go here and let me do this, and I take all these points, and I drag them again until 10,000 points, then you will see that the accuracy will be much higher. So let me see, let's say 6879. So 6879. So we have 6870 because 9 points are here, and then the sum, so now you can see that if I have more data points, then the value of the pi is more accurate. So now the fluctuations are less, and we are very close to the value of pi. So I hope this video helps, and I'll see you again in next video. Thank you. Hi everyone, in this tutorial we'll talk about the simulation of random walk of large number of particles. In the previous tutorial we talked about the simulation using Excel sheet of one particle, and here I will show you how to simulate the random walk for large number of particles. So let's define the particles first. So let's say I have particles ARD, particle 1, and then I have particle like this, like suppose I have 100 particles like this, and then define the position. So let's define time is equal to 0 and position x and y are both 0. So all of the particles starts at origin and so now this is our x and y. Now to define the movement, let's say time is equal to 1, and now because it's moving in the random direction, so we have to define a random variable. So let's assume that we want it to move in any direction, so and it should take a step either positive direction or negative direction. So how do we uh, simulate that random step? So for that we need a random number, and as I told you in my previous tutorial also, so random number in Excel is equal to rand and parenthesis. So this will give you a number between, so you can double click and say enter again, so you can see it give you a number between 0 and 1. And if you have to define a number between 0 and 2, you multiply this number by 2 and this will give you a number from 0 to 2. And if you have to define a number between -1 and 1, you subtract this number from 1. So how does it work is like, so it give you a random number between 0 to 2, and if you subtract it from 1, then it will give you -1 to 1. So suppose if I get a number less than um, 0.5, because from rand I can get mine less than 0.5. So if I multiply by 2, it will be less than 1, and then if I subtract it from 1, it will be greater than 0, and if same way I can get less than 0. So you can think about it, and it's not that tough. So now we defined this number, and same way we can define this number again, and you can see I have two numbers. And then what I can do is I can take this step and add the initial step into it. So I say initial step plus this step. So this is not difficult, and you can say enter, and similarly I can drag it here, and you can see, so for y also I added a random number. So this is your movement at time 1, and you can drag that again into the 100 particles, and you can see, so this is your position at time 1. Now what I'll do is I'll copy the same thing and paste it here. So what will happen, because this is the beauty of Excel sheet, that now because I copied it and I didn't put any dollar signs on the numbers, I can see, you can, if I double click on this and check the formula, so what it does, it automatically moves the cell from B4 to E4. So now you can see that now I'm adding a random step to the position which was there at time is equal to 1. Now you can see that, so my position, so this is my position at time 1, and this is position 2, and I can do the same thing again and again, so as many times I want. So I say V, and then, so let me, I'm not updating the time again and again, so let's delete the time and then do it again and again. So you can see, you can see this, that I can generate the walk like this. So actually if you use VBA, then you can do this automatically, you don't even have to paste this, but this is more of a conceptual programming. I wanted to show you the concepts, and that's why I'm doing it this way, because this make it much easier to understand. Otherwise you can just update the same cell again and again. You can see my simulations, some of the simulations I've shown, that it's not a tutorial but just a demonstration on how you can generate the movement of the particle. There's a nice animation on the another YouTube video, but here I'm just showing you the concept. So now you can see, so let's see, if I plot this points, say insert and say points, so you can see all of the points, so all of the points are at 0. So you can see all of the points are here at 0. Now if I plot these points, you can see that they have moved with time. So you can see that they have diffused away, right? And now if I plot these points, so you can see they are much more scattered now. And now if I plot these points, so they are much more scattered. And because right now the scale is not defined, so that's why you don't see the difference. So I can define the scale, and then you will see the difference. So let's do that. So what I can do is select this scale and say format axis, and say fixed -10 and maximum 10, and same way for this axis, and say format axis fixed -10 to 10, and say close, right? And then let's delete this point, and let's take this point and say format axis fixed -10 and +10. You can see, oh, this one is format axis fixed -10 and 10. And now you will see the difference. So I can, let me make them same shape. Fixed 10 -10. This is already 10, but I want to fix it, so close. Now you can see the, so what I'll do is I'll double click on any cell and say enter. So you can see that at t is equal to 0, the particles were all at one place at 0, and then they diffuse away from the center, and with the time their movement from the center, or their distance from the center, increases, but it does not increase uniform, like the particles are not moving only farther away, they are moving in the random direction, but by probability some of the particle reaches farther away from origin as compared to the others. So this is just a demonstration of the concept. And if you know VBA, I have also provided a tutorial on how to use VBA. So in that case you can really use the animations, so you can animate this movement of particles, and the particles will move in the random direction. So this is the conceptual work, and I hope this will help you understand the concept which is behind simulating the random walk. So I hope this tutorial will help, and if you have any questions, please comment on the YouTube, and if you like the video, please do give us your feedback. Hello everyone. In this video tutorial, I will show you how you can use simple Monte Carlo simulation to integrate any function using the Excel. So I choose Excel because it is very visual, and I can show you how the concept for Monte Carlo simulation progresses. Now you can always do the same simulations in other programming languages too, but I do prefer Excel for at least the tutorial purposes. So let me start. So for Monte Carlo simulations, first requirement is a random number. So how will you get a random number? So if you'll say is equal to, and then say RAND and two parentheses, so that will give you a random number between 0 and 1. So you can always modify this. If you want a random number between 1 and 10, 0 and 10, then you can multiply this random number with 10, and then you will get a random number between 0 and 10, right? So now suppose I define a range. So now let's say this is my range for, and this is the range for x, and this is a range for y, right? Let me drag it here, and I'll say the lower limit is suppose 3, and for this one is 5, and for say 5, and let's say 7, right? So now what I can do is if I want a random number between 3 and 5, then I can say 3 plus bracket 5 minus 3. So I should not say 3 here, I should choose this cell so that I can change it later if I want to. So this is how it is. So now you can see, let me pull it here. Yeah, so now you can see this is a random number between 3 and 5. So this number will remain between 3 and 5. So we can do similar thing for y also. So now let's say it is x and this is now y, and I say is equal to 5 plus 7 minus 5 into rand. So now this is again a number between 5 and 7. No, so now I want to copy the same number um, to the next rows, and for that I want to keep the reference for this range same. So what I'll do is I'll put a dollar sign here, a dollar sign here, and same way I put a dollar sign. So putting a dollar sign will fix the reference, and when we move the cell, or we drag the cell or copy the cell somewhere else, then the reference would remain same. Now, so now you can see that if I drag it below, then this number is still referring to the same range, and this number is still referring to the same range, right? So let me uh, drag it down, and I'll try to generate around 5,000 points because that will give me a good statistics, but you can always choose it based on how much accurate numbers do you want, right? So these are the number of points. So now I'll also say I'll go up. Now you can see that I can change, let me change it from 0 to 5 and 0 to 7. So now these are all my numbers. So let me try to plot XY data and see how this data looks like, because that will better give us the idea of how this scattering is. So I'll choose this and say insert. So I remove the chart title and I remove this function. So now you can see uh, it is a rectangle which ranges from 0 to 7 or 0 to 5 in x-axis and 0 to 7 in y-axis, and it is filled with random points, but because we have lot of points, so everything in this rectangle is been occupied. So if I click on some cell and press it again, then you can see the rectangle changes a little bit and all the number changes, but still because there's a lot of points, everything is filled up. So this is our first uh, generation of so we generated the first rectangle, and now let me define a curve. So now suppose we want to do integration for y is equal to x. So let me take you a simple example. So our function is y is equal to x, right? So now what I'll do here is I'll say um, is equal to if y is less than x, then I will use X, otherwise I will just say 0, right? And I say enter. And same way here, if I say if Y is less than X, then I choose Y, otherwise I'll say 0, right? So it goes like this. So then I can just double click here, so everything is copied below. So now I can also simplify it. Instead of saying if Y is less than X, I can also say if this number is equal to 0, then say 0, otherwise this number. So that is a I did that because if later on I modify the equation, then I don't have to modify this number, this one. I can just modify this one. So now you can see that we have certain zeros and certain numbers. Whenever there is a 0, then Y is greater than X. So you can see here that Y is greater than X. But here Y is less than X, so I see a number here. So now let me also do another calculation, that is number of total data points. So how many uh, number I have simulated here. So I'll say 1 1. So no, I'll say 1 and I'll say this is equal to 1, and then I'll just double click here, so I'll get the 1 everywhere. But here I'll say if this is equal to 0, then 0, otherwise 1. Now here I will only get 1 when, so let me do this again. So I will only get 1 when these numbers have a value. If they are 0, then this will also be 0. So now I can say uh, is equal to sum, and I'll write it all the way down. Oh, sorry, is equal to sum. So these are total 5324 points, but if I use the condition, then the sum will be 1905. So out of 5324 points, I only have 1905 points in the condition, if which met the condition that Y should be less than X, right? So let me also plot this scattered this random numbers for you, which have this condition that Y should be less than X, and see how that looks like. So I'll do this, and then I say insert plot. So as you can see that Y is equal to X is a straight line. So now anything which is below the straight line is being used, but anything which is above the straight line is not being used. So this in a way is the area under the curve, which is what integration is all about, right? So now what I'll do is I'll calculate this area, but I don't know how to calculate. I know how many points are there in this one. So first of all, I know the area for this uh, rectangle, and that area is equal to, so I'll say total area, that is equal to so you can see that the side of the rectangle is uh, 5 minus 0, so 5, so this will be equal to side on the x-axis and side on the y-axis. So if I multiply that, that will be the area of rectangle. So I'll say 5 minus 0 into 7 minus 0, right? So this is our total area. So our total area is 35. Now you can see that if I need to calculate the area under this line, all I need to do is say is equal to, so this many points 5324 point corresponds to 35 area. So how much 1936 points will correspond to? So for that I'll say 35 into 1936 divided by 5324. So that is the area under the curve. So that is my value for integration. So let me also uh, put a name for them. So we'll drag it here. So we write this here, and so this is total points, and this is points under the curve. And this is our area under the curve, right? So now we have this um, system where we can modify the equation and we can calculate the area under the curve. But let me also do some more modifications. So now here you can see that I am choosing a random range 0 to 5 and 0 to 7. However, if we go to more complicated functions, then I need to modify this range accordingly to the function, so that I am independent of what kind of functions do I use. So for example, let me say that instead of y is equal to x, now I choose y is equal to x square. So I have two x's now, right? So if I so for to calculate that, what I'll need to do is I need to modify these conditions. So in this condition I had if y is less than x, so instead of that I need to say is less than x square, and then I need to double click on it. So now you can see that y is equal to x square is more of a parabola. So you can see now I have a curve here, but I also get this excess area on the right side, which I do not need. So right now I am calculating all the I'm calculating the area which is under the curve, but same time for total rectangle I'm also calculating the excess area. So how will I modify this? I'll modify this by changing the range. So in this case I'll say that y, so you can see that uh, so this is our x range 0 to 5. So y range I need to modify it to y is equal to x square. So I'll say is equal to 5 square. So now you can see that there is no excess area, and you can change the range anywhere and there will not be any excess area. So now suppose if I say 44, then it is still the same, or if I say 22, then it's still the same. So now you have a way to calculate the area under the curve by using a Monte Carlo approach. So let us test whether this is true or not, or whether it is. So we need to validate it and calculate the area under the curve using the traditional integration approach, and then match the number here. So so to check this, so now we know that the function is y is equal to x square. So if we take integration of this number, so integration will be equal to uh, x cube divided by 3, right? So you know, put here, this here, x cube divided by 3. So this is your after integration, and this is your function, right? So because our range is from 0 to 22 in x, then 0 will make everything 0, but for 22 what I need to do is say 22 cube divided by 3. So that is my answer. So 3549 is my answer, but Monte Carlo is giving me 3618. So so it is very close, but it is different because it's a Monte Carlo simulation. So it gives you number by randomly putting the points. So the more points you put, the more accurate your number will be. But suppose if I change a double click on any cell and press again, then you can see that the number changes, and this number will remain same because I calculated it, but our area under the curve will always change. So but this is how you can do integration by Monte Carlo simulation. So let us try to get some more complicated function just to make sure that everything works well. So let me see if I can change the range from, instead of using 0, let us do it between some other function like so 10 to 22. So I say 10 here. So remember, if I put 10, then you can see there is now I have this range. So this looks pretty good, because this is how if you this is what you wanted. But same way we have not modify the y here. So to modify, so if you, so to modify the y, we also have to say is equal to 10 square. So now I don't have this this. Oh no, in this case we'll not modify the y. So you can see, so yeah, so this thing needs to be remembered. So if we modify the y also, we also cut this lower part, which we don't want to cut because we want area under the curve. So we will not modify the y here. So y will always remain 0. So now let's play around with it. So in this case, I need to also change this function. Let me do the calculation for integer which we did manually. So I'll say so this will be our range. So I'll say um, instead of 22, I'll give the reference of this x range, and then I'll put it in the bracket, and then I'll subtract the other x. So because now it is not 0 anymore, so when we integrate, we have to after we get the function, we have to put the upper value and the lower value. So I'll do this. So now this is our number, and now you can see that the numbers are again pretty close when you come look at uh, the manually calculated integration and the one with the Monte Carlo simulation. So now if I put it to any number, like suppose so now let me show you. So this is our curve. Yes, so let me show this. Yes, so now let's say we modify this to this number to 65.4, and this one is 55.32. Then you can see that we choose a small curve, and we are calculating the area under the curve. So manually it is 37176, but using the Monte Carlo simulation is 37464. Hi everyone. Today we received a request from one of our subscriber that he wants to do a simulation for finding the integral for two of the function as shown here. The first integral is minus 2 to 2 e raised to power x plus x square. So how would we do this simulation in Excel? So today I'll show you how we can do that. Before doing that, I'll just give you a small uh, tutorial on what the integration is all about and how simulation is used. So suppose if I have a function y is equal to x, then if I plot this function, it will look something like this, and this is y and this is x. And if I want to do an integral of this, then this will look something like that, x dx 0 to 2. So in that case, what I'm asking is that I want to calculate the area under the curve from 0 to 2. So if this is so I want to calculate the area in this region. So if I do the integration here, integration will look something like that. X square by 2, 0 to 2, or that will be equal to 4 square, oh sorry, it should be 2 square divided by 2, and that will be equal to 2. Another way to do this same thing is to just look at this triangle, and this is 2 and this is 2, so this is the area of a triangle. So area of the triangle is equal to half into base into height, so that will again give us 2, right? So the third approach to do the same thing is by simulation. So what the simulation do is that it takes y and it multiply this by dx and then takes the sum of it. In that case the dx should be very small, right? So if you look at the integral, so suppose if I have a line here, so in that case this is called dx and this is y, right? So if I calculate the area, I have to calculate the area of the strip. So if dx is very small, this strip can almost be considered as a rectangle, and the area of a rectangle is equal to y into dx, where dx is one of the side here and y is another side, so that's almost equal to a rectangle. So if we add all these rectangles together, then we'll get the area. So I'm using this approach to calculate the area of this function, and then I'll use the same approach to calculate the area which our subscriber has asked for. So let me begin in Excel. Now we are in Excel. So suppose if I am want to do integration from x1 and x2, so x1 is suppose is 0 and x2 suppose is 2, and we want to calculate first the dx. So how small we want to go for dx? So let's say that we divide this range into 500 equal distances. So in that case I'll say x2 minus x1 divided by 500. So now dx is very small, it's 0.004. So now let's say that I now simulate x. So my first because I start with x1, so I'll say that my x is x1, which is 0, and then the next x or next increment would be x1 plus this dx, and I'll put a dollar sign here because when I drag the cell down, then the reference for this cell will not change. So now if I, you can see that if I drag it down, there is increment from 0.004 to 0.008, and if I click on this, then reference is still the same. However, the reference A7 has changed because there is no dollar sign here. So now I can do the same thing, and I keep dragging it, and so you can see that I just need to reach until um, 2. So now you can see that I have reached 2 here, and you can see the number is 506, and I started with 6, so there are total of 501 points. So now if I calculate y, so because our first equation which we want to try, let me say insert here, and the equation is y is equal to x, right? So in that case, if I put y is equal to x, so I just need to say y is equal to x, and then double click here, so I get x and y, and then I can plot these two functions together. And this is how I get the same line as I showed before. And now to calculate the area, all I need to do is add all the y's together and then multiply by dx. So the answer should be equal to sum, and then add all of these together and then multiply by dx. So that's my answer. So you can see the answer is, so answer is 2.004, which is very close to 2, which we calculated theoretically. Now let's go to the request question. So if we go to the request question, that was why, so in this case we start with the problem A. So x1 is -2 and x2 is still 2, and then the equation changes to something else. So in this case, y is equal to exponential of x plus x square, right? So that's all we need to do, and then double click on this one, and now you can see that this is how the equation looks like. And if we calculate the area under the curve, that should be our answer. So it is that simple. Now let's go to the problem 2. The problem 2 is little trickier because here it says that x1 is 0 but x2 goes to infinity, and we don't know what that infinity means. So let me keep it to 2 right now, and let's see what we can do. So here I'll say y is equal to x into 1 plus x square raised to power -2, right? So if I do this and then double click on it, and now you can see that this is how the equation looks like. So now because it goes from 0 to infinity, let me try putting 5 here. So if I put 5 here, then you can see that our curve is approaching 0. Again, if instead of 5 I put 10 here, then it further approaches 0, and even if I put 100 here, then it goes to approximately 0. So you can see that the answer is not changing. If I put 100, it's 0.49659. If I put 20 or not, sorry, if I put x2 as 20, it's 0.49862. So it is still approximately same. So we can safely assume that the answer for this should be if we round off, it should be 0.5. So in that case it doesn't matter. For simulation we can either go to very high number, or still we can only do it simulation until 20. However, be cautious here, because if you put a very high number for x2, like suppose if I put this high number, then my number will change here because my dx is very different. So because dx is different, it straight away goes from 0 to then 6000, and you lose all the simulation which, or all the area which you need to calculate around 1, because you can see that the peak was around 1. So you can't do that in this case, so we have to be careful in that regard, right? So I hope this tutorial help, and if anyone has more request, they can always submit that request to me by my email, or just leaving a comment on the under the video, and I'll try to help in that case. Thank you.